Hello everyone, welcome to another video by Maths with Sarah. So today we're going to be looking at this question that involves prime factors and lowest common multiple. Now this is something that I find a lot of people get stumped by, and actually it's not that complicated. So what I would suggest is pause the video round about now, have a look at this question, see if you can figure out what the answer is. If you can, great. If you're struggling a little bit, do as much as you can and then come back and watch the rest of the video and I'll talk you through it. Okay, so hopefully you've had a chance to have a little bit of a go of this. The first thing to remember is, what does this mean? So what is a prime factor? What does it mean when it asks you to write a number as a product of its prime factors? So a prime factor is any number that is a prime number and a factor of 84. In this case, it's a factor of 84. That is a prime number. So your prime numbers are numbers like 2, 3, 5, 7, 13, 11, any number that is only divisible by itself and 1 is a prime number. So quite often they're pretty much all odd numbers with the exception of 2. And they don't have any other factors. So for example, 15 isn't a prime number because it's got 3 and 5 as factors, as well as 15 and 1. Whereas 11, the only 2 factors are 1 and 11. So that covers what a prime number is. A factor is any number that this number is divisible by, or anything you can times by something to make 84. So they're all whole numbers. So if we're going to write 84 as a product of its prime factors, the way that I find it easiest to do this is very visual. So we're going to make this into a bit of a tree. So each time we're going to divide this number by a prime number, where it's a whole number, so i.e. what we're going to find its factors. So 2 is a prime number. 2 is also a factor of 84 because the last digit is an even number. So we can divide this by 2 to start with. Nice and easy. So we've got 2, prime number. Now, what is 84 divisible by 2? What's the other factor that we need to put next to 2 in the tree? So if we do each of these digits divided by 2, we do 4 divided by 2, we get 2. If we do 8 divided by 2, we get 4. So we've ended up with 42. Now, is 42 a prime number? Well, hopefully you remember what I said at the start, that even numbers are not prime numbers with the exception of 2, because they are divisible by 2. So we can divide this again by 2, same prime number that we used before, which is a factor of 42. Now again, what is its partner? What do we need to times 2 by to get 42? Again, we'll divide each of these digits. So 2 divided by 2 gives you 1, and 4 divided by 2 gives you 2. So we've ended up with 21. Now 21 is back into the range where you're hopefully starting to recognise some times tables that have got 21 in them. We can see that it's not divisible by 2. So we'll just go up the times tables until you find a number that it is divisible by. So it's not divisible by 2. What about 3? Yes, we can divide 21 by 3 and get a whole number. So 3 again is a prime number. The only 2 factors of 3 are 3 and 1, so therefore it's a prime number. 21, what's the pair? What's the number that goes with 3 and multiplies to get 21? Hopefully you remember in your times tables, 3 times 7 is 21. Now we've got the last step. Is 7 a prime number? Well, can you divide? Does 7 have any factors other than 1 and 7? No, it doesn't. The only 2 factors are 1 in itself, therefore 7 is a prime number. So we've now got to the bottom of the tree, we've written it out in pairs the whole way down, and we've circled the numbers that are prime numbers. This is as far as you can break this number down. So we know that 84 as a product of its prime factors is 2 times 2 times 3 times 7. Now, if you were to put this sum into a calculator, you should find that it equals 84. And yet, if I just do the maths very quickly, it does equal 84. So we can be pretty sure that we've got this right. And we can check, are each of these numbers prime numbers? Yes, they all are. They've only got two factors, 1 and themselves. Therefore, we've been able to break 84 down into a product of each of its prime factors. Excellent. So that's question 1, part A. What about the second part? So this is where it gets a little bit more complicated. We've got to use a few more skills to figure out the answer. So what it's asking you to do is to find the lowest common multiple of 60 and 84. So the best way of doing that is to break each of the numbers down into their prime factors. So we've done this for 84. We know that 84 is comprised of 2, 2, 3, and 7. What about 60? So let's do exactly the same as we did for 84, but with 60. So again, we'll start off by dividing it by 2 because we know that it's an even number, so we know that it's going to divide by 2. What's its partner? Well, hopefully you are aware that 60 divided by 2 is going to be 30. Now, is 30 a prime number? No, again, it's even, so it's not a prime number. So we'll go again, we'll divide it by 2. We know it's an even number. It can be divided by 2. So if we do 30 divided by 2, what's half of 30? A little bit more difficult, but it's 15. So is 15 a prime number? No, it ends in a 5, so therefore we know that it's a multiple of 5. This is obviously an odd number, so it's not divisible by 2, but we know that it is divisible by 5. So if we go up in the 5 times table, we know we can work out that 15 is divisible by 3 and 5, or rather it's the factors of 15 are 3 and 5. Now, both of these numbers, hopefully you're getting the idea, are both prime numbers. So 3 and 5 and 2 can only be divided by the number itself and 1. None of these can be divided by any other number, and therefore we found the prime factors of 60. So we can write down again that 60 is, as a product of its prime factors, is 2 times 2 times 3 times 5. Okay, so we've got to this stage. We've drawn out factor trees of both of the numbers, and we know that both of them, written as products of their prime factors, are 2 times 2 times 3 times 7 for 84, and 2 times 2 times 3 times 5 for 60. So what's the next step? The next step is we're going to draw a Venn diagram. Now, again, you can work this out in many different ways. The way that I find it easiest to do is to draw it as a Venn diagram. Then I think it makes it really straightforward why you're multiplying the numbers that you are. So if we draw a pair of circles here, in this box here, we'll write all the numbers that are, in this circle here, we'll write all the numbers that are prime factors of 60. And in this one, we'll write down all the numbers that are prime factors of 84. And in this overlapping bit in the middle, we'll write down the ones that are factors of 60 and of 84. Okay. So we write that down. Both of these have a 2, so we can put a 2 in the middle. Both of them have got a second 2, so we can put a second 2 in the middle. Both of them have got a 3, so we'll put a 3 in the middle. 7, 60 doesn't have a 7, so we need to put the 7 in this side of the Venn diagram next to in the 84 circle. And the same is true for 60. So 5 is only a prime factor of 60 and not of 84. So we can put it in this side of the Venn diagram circle. Right, so we've got the 3 overlapping factors, the three numbers that are factors of both 84 and 60 in the middle, in the overlapping part. We've got the number that's just a factor of 60 in this half, and the number that's just a factor of 84 in this half. So now, what do we do to work out what the lowest common multiple is? Well, the easiest way to do this is to just multiply all these numbers together. So that means we're only timesing these once because there's an overlap, so we just put these in as they are. So what do we get? So the lowest common multiple of 60 and 84 is equal to 5 times by 2 times by 2 times by 3 times by 7. Now, luckily this is a calculator paper, or you'd be having to work this sum out in your head. It's a little bit more difficult, so I suggest you use a calculator for that unless you fancy some really quick mental math. But I can tell you, from having worked it out, that the answer you should get is 420. So this, I think, is the easiest and most visual way of working out what the lowest common multiple is. So we can, so by doing it this way, it's really straightforward. You include all the numbers if you're working out the lowest common multiple. We're remembering what a prime factor is. We remember that a factor is a number that's divisible, or something that you can multiply by another number to make the total number. A prime number is something that can only be divisible by itself and another number, itself and one. And the lowest common multiple is the number that the smallest number that you can, that is a multiple of both 84 and 60. So you can times 60 by something to make 420, and you can times 84 by something to make 420. And this is the smallest number that both 84 and 60 are factors of. Okay, hopefully that made sense. Hopefully you followed what I was doing the whole way through. If you have got any questions, feel free to drop me a message. And I'd also encourage you to like and subscribe this video so that it can be passed on to as many people as possible, and also so that you are aware of every time I bring a new video up. But lastly, thank you very much for watching, and I really hope you find it useful.